Hello everyone, welcome back. Today we are mastering Linux file permission. Permissions control who can read, write, or execute files, and understanding them is critical for DevOps. So for web server, CI pipeline, automation scripts, all depends on correct file access. If file permissions are misconfigured, users cannot run. App fails to write logs or sensitive files. To avoid all this kind of misconfiguration, we must understand Linux file permissions, ownership, ACLs, and umask. Okay. For example, if I am doing ls-l slash var, okay, in root, I can see all the folders and files inside var folder. So I'll go to server. Currently, I am in root. Okay. So I'll type ls-l slash var. Okay. Now we can able to see the folders and here you can see we have to understand all these things. So here it is starting with D, right? D stands for directory. Okay? If it is starting with hyphen, then it is file. So since backup is the directory, it is started with the D. You can see all the directories are started with the D. So by seeing permission itself, you can understand whether that is a file or a directory. If it is a file, then it will start with I. Okay? If it is a directory, then it will start with the D. And you can see the permission. So let me explain. Just we will copy one and we will paste in a whiteboard so I can. This is the permission that we saw in our server, right? So this D indicates it is a directory, right? Directory. If you want like you can ask for files how it will start. It will start with hyphen file. Okay, this is a directory. Okay, and you can see this permission. Right? So this only we are going to learn now. Okay. So there are three things you need to know. Okay. First is owner, group, others. Okay. First, like it will start with owner. Okay. Before that, you need to understand permission numbers, all those things. But we will discuss that okay later. First, we will start with this. R for read, read. W for write. X for execute. Okay. So this first three belongs to owner or W. Okay. Second, you can see hyphen, right? So there is no write operation here. We have X or only. So it belongs to group belongs to or hyphen. You can write like you can write hyphen X or hyphen X. Everything is so others. Others is so this three belongs to owner. This three belongs to group. So this three belongs to others. Others also have hyphen or hyphen or hyphen X. Read and write. Like owner has read, write, execute, but group and others have only read and execute permissions. Okay? And you can see this two, right? This two is a link count. Link count. Okay? And first one, this root belongs to owner, and this root belongs to group. Okay, and this is the size. It is in bytes. Guys, it will be in bytes. Okay, 4096 is the byte. Okay, and this is the timestamp. and this is the file name. Okay, so this is the this we have to understand. Each plays a major role. Okay. Now, if you do ls anywhere, ls hyphen l anywhere, you know, okay, by seeing this permission itself, you know whether it is a directory or file, and you know the purpose of this root, this purpose of this root, and purpose of this root, and 4096, everything you know. Okay, so this is permissions, directory type and permissions, link count, owner and group, size, timestamp, finally. Okay, so now you understood the file permission. So now you understood the file permissions. Now you need to understand change permission. Change permission. We're going to change permission. For changing permission, we will use chmod. Okay, so we learned, right, read, write, execute. Read, write, execute. Each has some value, read, write, execute. Right? Each has some value. Okay, you need to understand that each has some bits. Okay, in numeric mode, read value equal to 4, write value equal to 2, execute value equal to 1. So overall 7. Okay. So in permission, if you see this read, write, execute 7, right? Read and execute only there 5. Read and execute 5. So the permission of this like a permission number for this permission is 755. This is how you have to calculate the permission in numeric mode. Okay. So as always I said, first it will start with owner, next group, and others. Okay. So owner has read, write, execute. Group and others has read and execute only. They will not have write permission. Okay. So if you want to create a file, okay, for owner you should have read, write, execute. But for a group and others, they should have only read and execute. Then you can go with 755 permission. Okay. Let's deep dive into it. Understanding file permission. Linux file. Understanding Linux file permission. Every file and directory in Linux has three categories of users and three types of first is user category. In this category is, okay, who the permission applies to. Okay, so first you for user by owner. Okay, the one who created or owns the file. G for group. Okay, a group of users that file belongs to. Okay, O others, which means everyone else. A, which means all, shortcut for user plus group plus others. Okay, so while coming to permissions, as we discussed, while coming to permission types or for read, okay, view the file contents. Okay, read what can do is it can view the file contents or list directory. W for write, okay, modify the file content or create and delete a directory. Okay, if you have write access, you can even delete a directory. X stands X purpose is execute. Okay, run the file as a program or enter a directory. So this is the permission type, read, write, execute. Symbolic mode examples. For example, if you know symbolic mode examples also, it will be useful. So while coming to symbolic mode examples, example one, for example, I am using chmod, okay, g plus w, okay, and I am just providing one file called file.txt. Okay. This G stands for group. Okay. Plus is add permission. Plus indicates add permission. Okay. This W indicates write. So meaning add write permission for the group. If the file was originally, for example, this file original permission is or w hyphen or hyphen, which means owner owner has like read and write, which means 4 plus 2 6. Okay, group and others has only 4, means 644 is the numeric permission number, like numeric in numeric mode the permission is 644. Okay, if the file was originally 644, if you execute this command, okay, it will become hyphen or w hyphen or w hyphen or hyphen hyphen, means owner will have 6, group also will have 6, others will have 4. So we are changing the permission from 644 to 664. Okay. Mostly in real time we will use numeric numbers only instead of the symbolic mode. I'm just explaining, if you want you can use symbolic mode also. Okay. For example, okay, if I am using again, okay, again I am using chmod, okay, o hyphen r file dot txt, okay, which means o for others. This hyphen indicates what? Remove permission. It is plus means add permission. Hyphen means remove permission. Okay. So removing read permission from others, everyone not owner or in the group, right? So before what we add, so this is like consider before we add this group, okay, which is 664. After executing this, it will change hyphen or w hyphen or w hyphen 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 hyphen. So others cannot read the file now. Okay, let's try this practically so you will get good understanding. First, we will create one file. I'll just go to home Ubuntu. Okay, so I'll just create one file called file.txt. Okay. So this is I'll just add some sample content, like this is testing file. Okay, so first we will set the permission as 644 as we discussed. So, sudo chmod 644 file.txt. If I do ls -l, now it is in 644. Can see 644. Now, with the help of this command, we are going to change this to 664, which means owner and group will have read and write. Okay, others will have only read. Okay, to do it, to do this, what is the command? Sudo chmod g plus w, g for group, plus for add permission, w for write. So file dot txt. Now if I type, if ls hyphen l, it has read write. Okay, owner has read write, and the group also has read write. So 6 6. Okay, and it others will have 4, read only read permission, means 664. Now we are converted into 664. Okay, now again I am going to use o hyphen r, which means it will I am removing read permission for others. So only owner and group will have read and write access. Others will not have any access. To do that, again sudo chmod, okay, O for others hyphen means remove permission or read, okay, file dot ext. If I type ls hyphen l now, here you can see, okay, this is file, so we are getting hyphen here. Okay. If it is a directory, then it will be a D. Since this is a file, this is hyphen read write. So, like read write execute, we don't have execute permission. So owner has read and write. Okay. Group has read and write. Again, group also don't have execute permission. Others have zero permission, okay, which means owner and group only can read and write. Even they can't execute. Owner and group also don't have execute permission. But while coming to others, others cannot read the file itself. Okay, so this is how we have to work with this. If you have any doubts, just mark that timestamp in the comment section and comment your doubt. So I will reply for you. So this is how it works. Now is recursive mode. Now we will discuss about recursive mode. Okay. When applying permissions to directories with many files inside, we often use hyphen r, which is recursive. For example, chmod hyphen r 755 where www html. It's just a sample path. Okay. Here hyphen r apply recursive to all subdirectories and files. This 755 is a numeric notation, which means owner has read, write, execute, which is 7, and group as only read and execute, which is 5. Okay. And others as read and execute, which is 5. So the permission is 755. Meaning all files and directories inside where www.html will be set to owner will have read, write, execute, and group and others will have read and execute permissions only. The problem is files don't always need execute permission. You don't usually run an HTML file, am I right? So this can be unsafe. So what we learned? We learned about symbols and its meanings and examples. Let's have a quick summary. After that, we will go with ownership. So since most of you are a beginner, okay, let's have a quick summary what we discussed. Summary: symbol, meaning. So you means user or owner. Okay. Like for example, chmod, okay, u plus x file dot sh means what it indicates owner can be execute. Okay. Next is g. G is group. Okay. For example, if I use chmod g hyphen w file dot txt, which means remove right from group. Okay. So o is others. Okay. For example, chmod o equal to or file dot txt means others can only read. Okay. Next is plus. Plus means what? Add. Okay. So uh, like it indicates all. So chmod a plus x file dot sh means everyone can execute. A for all. If I use hyphen, which is remove. Okay? If I use chmod o hyphen r file dot txt, so we are just removing uh, like a read from others. And now this is so okay, uh, file permission. So you know the symbol and meaning and how it works. Now we will start ownership. Ownership. For ownership, we will use ch own under ch group. Okay. So the thing is, like for example, if you want to change owner and a primary group, then you can use ch own user group, and you can provide file. What it will do, it will change owner and group, primary group. If you use a ch group and file, it will change only group. It will change only group. Okay. So again here you can use hyphen or for recursive. For example, let's try this. So let's go to server. Okay. Now we have already ops team, right? So like we have ops team and we have one user called CI render. So I'll use ch1 user and group file. Okay, and we will try to change ownership and group permission, primary group. Sudo ch1 ci hyphen runner and the group. I'll provide a ww hyphen data on deploy like on ci runner ci runner slash dot such dash authorize the key. We will go with this. So if I execute this, it doesn't have any .ss folder. So what we can do, we will create one user uh, called deploy. Again, we will create a user called deploy. Okay, previously we done it, right? So how to do it? Did you remember? Do you remember like how we created the deploy user? So with the help of add user command also. So add user deploy. I didn't change it. So I'll just one thing. So now if I type pwd, I am in home Ubuntu, I'll come out of this. You can see the deploy. So I'll use sudo, but I'll just type sudo ch1 deploy ww data home deploy dot dot sh. It is showing no file or no such file or directory. Why we are getting this issue? Yeah. Just pause the video and let me know why we are getting through and how to in command section. So I can understand whether you understand properly or Why we are getting this issue? The thing is, what we are doing, ch1 means change ownership, user and group. We told change owner of home deploy.sh to user, okay? Deploy, okay, and group to ww-data. But Linux is saying I can't find home deploy.sh. It doesn't exist like that. It's why it's a SSH configuration folder for the deploy user. Okay. Usually created automatically when we are logging as a deploy with SSH, or manually created with like authorized key. So since it is not there, then now we can fix this. For example, if I am using sudo mkdir slash home slash deploy dot ssh. Now it has created the dot ssh. Right? So I'll just change this permission to 777, like 700. 700 means owner will have rewrite execute, group and others will have no permission. So chmod, I'll just provide 700. I'll provide deploy dot ss. Now I'll try to execute this command. Now it was executed without any issues. Right? So now if I type ls-l slash o slash deploy dot ss, we are getting permission. I'll just use sudo. Okay, we don't have any file here, but I'll do, I use home deploy because it is a hidden file, right? So I use a, you can see group is ww-data, and we change the group. This is how you have to. Even you can use ch1 with hyphen or and you can provide like only if you want to change only group, then you can provide only group. It's based on your need, you can use the command. Now we will learn special permission bits and umask. Any idea on this? As a DevOps engineer, you must know this also. Special permission bits under umask. Okay. Linux permissions normally work with the read, write, execute for owner, you, group, me, and others. But behind the basic read, write, do, there are some special permission bits that give extra behavior. First is SUID, okay, which is set user ID. Second is SGID, set group ID. Third is sticky bit. Fourth is umask, default permission mask. Okay, so let's start with set user ID. SUID, meaning when a file with a SUID bit is executed, it runs with the privilege of the file's owner, not the user who executed it. For example, if I type ls-l, okay, slash user slash bin password, okay, we will get something, right? So Let me show you that so you can understand it in better way. Okay, some file by default it will be in SUID. One of the file is user bin password. I'll just use ls hyphen come out of this ls hyphen slash user slash bin passwd. So us here you can see previously we saw read write execute only, right? So this is a file, so it's starting with like iPhone. That is okay. Okay, but have you ever seen till now with four permissions? We will see our read write execute, but here you can see read write yes or what this indicates. Have you ever noticed previously this yes in a user bin password? The thing is normally we will have execute, but here yes it's SUID set. Why? Why we have to set why this file password file as set id? Any idea? The password command lets normal users change their own password, but password hashes are stored in slash etc slash shadow, which is only writable by root, right? So password runs with root privileges. So file owner equal to root, allowing you to update your password. Okay, but while you are using like SUID, you should be careful because if you run that file, okay, it will run as a it will run with owner permission, not with your permission. Okay, so only you can update your password. Okay, for example, I have created a deploy user, right? So if I the deploy person wants to change the user, also they can able to change it because it has set ID. Set ID means while he is executing that command, he will run that file in owner permission, not on deploy permission. And it has security risk also. For this kind of files, you can use set ID, but generally you should not use it. For example, if a program has SIUD root, it could be used to gain unauthorized root access also. That's why SUID files are carefully monitored. For example, we will create one folder mkdir binary. Create as my binary. Have to use sudo. Okay, if I use ls hyphen l, where is my binary? It is just a folder. Okay, what permission it has? Read, write, execute. Owner has read, write, execute. Others have read and execute. Means in numeric mode 7, 4 plus 1, 5, right? 7, 5, 5. Okay. Now I want to set SUID. Then what I can do is, what we can do? I can use chmod u user plus s. Okay. My binary. So, if I type ls hyphen l, this my binary also has set user ID. This is how you can provide set user ID for any folder. Okay, but be careful when you are using this. Now, even if your normal user runs my binary, okay, it execute as a root. Okay. Think of SIUD is like a master key loaned by the files owner. If the owner root puts SUID, anyone running it gets to temporarily use that master key while the program. So this is the purpose of SUID. Use carefully if you are planning to use it. Okay. Second is SGID. Okay. meaning it works in two different ways depending on whether it's on your file or directory. So, for example, yes, first we'll discuss SG like ID on file. SGID on file. Okay. So file runs with the group privilege of the files group, not the users group. For example, now again, okay, for this my binary, now I am going to give sudo g plus s means SIID on file. Okay, it's a folder, right? So what I'll do is I'll just enter into my binary. I'll just create one file called text test. Okay, I'll just save this. Or if I use cat test, it's just a sample file I have created, right? So chmod. Now if I type ls -nil, it has normal permission. Now I am going to use we are going to use SGID, set group ID. Okay. Sudo set chmod g for group plus s and the file name is test. Now if I type ls -nil, you can see s or here s appears under the group. Previously you saw s in the owner, right? Since we are using that group, it is that s is reflected on the group, under group. If someone runs this, it executes the root group formation. Okay. Previously we discussed about owner. Okay. Now it is group. So even you can execute SGID on a directory. For example, I'll come out of this. I'll change group. I'll change this group to Ubuntu. Ubuntu my binary. Use root. If I type ls -n, where is that binary? So you can see group is Ubuntu now. Now I execute chmod g plus s my binary. Again I have to use sudo. Now if I type ls -l, you can see s here also. S in group and S in owner binary. Yeah. S in owner as well as in group. Okay, which means any new file created inside it will automatically belong to group Ubuntu, even if it is created by another user. Okay, while coming to SGID on your file, it's like saying whenever this tool is used, act as if you are part of my team, this group. SGID on your directory, it's like a shared toolbox. No matter who adds new tools, which is files, they all stay in the same group drive. Okay? Now, sticky byte. Any idea on sticky byte? Like a sticky bit. Sticky bit. Meaning applied only on directories. Parent users from deleting files that don't belong to them, even if they have right access to the directory. For example, you know temporary folder, right? So if I type pwd, okay, ls-ld/tmp, you can see T here. Why we have T here? Have you ever noticed temporary folder at the end it has T? Because slash tmp is a world writable. You can see read write execute, read write execute, read write execute. Okay. Without this sticky bit T, Anyone could delete anyone else files in temp folder. Okay? With this sticky bit T, users can only delete their own files. Okay, so for example, we have created my binary, right? So I'll provide chmod plus T for sticky bit, and I'll provide my binary. Again, I have to use sudo. If I do ls -l, where is my binary? This is my binary. Okay. We go to my binary. Hmm. So temporary, I have provided my actually I have wrongly used. What I have used hyphen T, but what I have to use plus I plus hyphen. I'll come out of this. I have executed it in wrong command. So the correct command is plus. I should not use remove since I am adding it. Okay, now if I use ls hyphen l, my binary, you can see the T sticky bit. So what it will do, users can delete their own files only. So sticky bit, anyone could delete anyone's files in the temp folder. For example, where you can use this sticky bit is if you are creating a folder, okay, and you are providing read write execute access for anyone. Then if you provide this, users can delete their own file. They only delete their own. Okay. Imagine a shared apartment which everyone can put food in, which is right access, but you can't throw away your roommate's food, right? That's all exactly what sticky bit enforces. Okay. Finally, now we are going to discuss about umask. Okay. Umask and ACLs. Any idea about umask? Any idea? Have you ever heard about umask? Umask stands for under mask. Right? Umask, which we call as user default permission. Meaning umask sets the default permission a file or directory is created. Default rules in Linux is new files start with 666 files. New directories start with 777. Okay. Then you must subtract the permission. Okay. For example, if I provide you must as 022, okay, which means default file is 666, right? So 022, what it will do? It will remove group and other. Okay, it will remove group and other write permission. So it will become 644. Okay. So for example, default directory will be 777, right? So for what it will do, again you mask default directory is 777. If you use 022, it removes group and other write. So that 777 will become 755. Okay. So this is for files, uh, directories, and you can use even umask 027. What it will do, umask 027. Okay. So files will become 640. Okay. And a directory will become 750. Okay, which means 777. Okay, 027 means 057, right? This is for directory. For group, okay, 666 you will provide means 027 means what will be the permission? 640. This is how it works. Think of umask as the lock system on new mailboxes. By default, every new mail which has files and directories open, umask decides which locks are closed by default and when the mailbox is created. You can use umask for changing the permission. Okay. If there are any doubts, or if there is any doubts, you can drop a comment so I can read and reply to you. Next is ACL. Why we need ACL? First, you need to know the expansion of ACL. Anyone knows purpose of like the expansion of ACL stands for Access Control List. Okay, so traditional Linux permissions only has three layers, right? So by coming to three layers, one is owner, second one is group, third one is others. Okay, so generally you will have owner, group, and others one. But what if you want a deploy user to also have read write and www-data service user to also have read write execute without changing the file owner or group? It's possible. Yeah, it's possible with the help of ACL. They let you grant fine granted permission per user or group independent of traditional user group or other model. Okay, for example, okay, consider like I'll open one folder. We'll go to Ubuntu. We will create one folder called demo. Yes, it's a demo. So user has read write execute, group has read write execute. Okay. While coming to others, will have read and execute only. So the permission will be 775, right? So how you can use like to modify it? For example, while coming to view ACLs, you can use f get f ACL and demo. Actually, we have to install this. Okay, by default, you will not have this ACL command. You have to install. So I'll install ACL. First, I'll update the server. After that, I'll install. So apt update. Copy this. Getting it. I hope you understood ACL, right? Like in traditional, we have three layers. Okay, but if you want to do, for example, if you have a deploy user, you want deploy user to have read write, and you want wwi for data service to also have read write execute without changing the file owner or group, then now it's possible. That's where ACL comes in. So now we will execute that ACL. And now we have installed it. Get f ACL demo. You can see file is demo, owner Ubuntu, group also Ubuntu. User has read write execute, group has read write execute, but others has read and execute only. Okay. But you want to add extra entries for user and group with custom permission, then you can go with ACL. Okay. For example, I want to include a CI runner in this as a user. So then now I can add the ACL for that. You can use set f ACL -m stands for modify u CI hyphen runner, this is one of the user. Okay, and for CI hyphen runner, I need read write execute, okay, which is like what we are doing. We are just giving user CI runner, okay, to read write execute for demo folder. Others after this, even if the group or others don't have access, the CI runner explicitly does. So let me execute this. Now again I use get demo. You can see for CI user we have read write execute. This is how you have to add the ACL, and you can even recursive ACL also you can do. Okay. For example, you can like how you can use recursive ACL. Set f ACL hyphen R for recursive. Apply recursively to all files and subdirectories. Okay. Hyphen M modify D D colon is a default ACL. Applies automatically to new files directories created inside, which is to user under CI hyphen run read write execute demo. Where is it? Set F L hyphen oh, CI runner. Use the XI runner. CI runner read write execute. Now again, if I use get F demo, see the details. For example, now I'll enter into CD demo and I create one folder file called vi file one dot txt demo. If I do ls hyphen okay, you can see this right. And even if I use set yeah, get f get f ACL demo, so we are inside the get f demo. No, the thing is, since it applies default ACL, which means applies automatically to new files and directories created, right? So it will be useful in project directories where every new file should be writable by CI runner. Now every new file can be written by CI runner. So only you can see file demo owner Ubuntu group Ubuntu. Okay. For user CI runner, I have read write access. Okay. What this integrates? What you understood? Okay, let me know in the comment section. So let me explain this. So if I explain this one more time and understand it better, let me explain. So the major reason for using ACL itself, you know that, right? So we are just if you want other users to provide some permissions. For example, my CI runner should have read write execute permission, and you have one service, and that service need read write execute. If you want to customize the permission, then you can go with uh, ACL, right? Here we are using get ACL. Get ACL means get file access control list. So we can see the list. Normally, Linux users use a group other permissions as we discussed, but with ACLs we can give extra fine-granted permissions. Allow one specific user full access without changing group ownership. That is a major advantage here. Here, first three things you can see, right? Like file is named as demo. Default user is Ubuntu. Default group is Ubuntu. Normal permission is user will have read write access, group will have read write access, and others will have read and execute, which means user or WX. The owner Ubuntu has read write execute. While coming to group, The group Ubuntu has read, write, execute. While coming to other read and execute only it has. Everyone else has read plus execute can enter directly list files but not read. So additional user ACL, which is CI runner, you can see user CI-runner RWX. What it do? This CI runner is there, right? It's not the owner. He's not the owner of the file, right? But it has been explicitly given read, write, execute on this directory. Without ACL, CI runner could not get any, could not get whatever group or others allowed. ACL makes it more flexible. For example, if you are using Jenkins or if you are using any third party tool and if you want to provide permission, okay, then you can go with ACL and okay, it provides more flexible. Okay, based on the need, you can update the permission with the help of ACL, and you can see the mask, right? Mask or read write execute. This mask is the maximum permission any user and group from ACL can get. If mask was read read and execute, then even though CI runner has read write execute is set, the effective permission could drop to read execute. But here we have read write execute. Okay? So here mask is read write execute. So full permissions are okay, and you can see the defaults, right? So these are default ACLs because we have used hyphen D. You can see. Okay? These are default ACLs. These are default ACLs. Okay. For new files directories created inside demo, which means any file or folder inside demo will automatically inherit this permission. For example, if we have created file 1.txt, CI runner will automatically get read write execute on that file. This is super useful in a shared project directory. Example, CI/CD runners, multiple DevOps engineer writing logs and code in the same place. Okay. So putting all together, the owner equal to Ubuntu, which has full access. Group is Ubuntu, which also has full access. But user CI runner has full access, okay, because of ACL. Okay. Others will have only read and execute. Default ensures future files inside demo inherit the same files. So, okay. Think of it like a shared office drive. Okay. So owner Ubuntu has the master key. Group, which is Ubuntu team members with duplicate keys. Others, visitors who can look inside but not change anything. But CA runner is an outsider. You gave your special key to. Default ACL means any new files put inside the drive will also allow CI runner access automatically. Okay, so this is how ACL works. This is how we have to use ACL. If you have any questions or doubts, you can message me on the comment section so I can explain. Okay. So if you like this breakdown, subscribe to CloudOpsCraft. We will simplify cloud and DevOps for every week. Thank you.